Hello and welcome back to another VMK in the game development series. In this VMK, we'll be going and creating two different kinds of geometries that will work with our scene graph. The first geometry, we're going to go and modify our existing flat grid class so that it works with the scene graph that we're building right now. The second kind of geometry that I'll show you how to make is the box. And in most games, you'll find a box is used quite extensively for things like crates, walls, anything that's kind of rectangular. It's a good idea to have a box class. So I'm going to go and show you how to create a box class. It's very easy to do, especially since we've now decided to go with the route of using the scene graph. So let's get started with the flat grid. Let's go into our project here, and underneath object lib, you'll see that we have the flatgrid.cpp and flatgrid.h. Let's open up flatgrid.h first. Okay, let's take a look here. Flatgrid.h. First thing we're going to do is rename our definitions here. Since we're going to be inheriting from our geometry class, which we created in the last VMK, we're going to change the defines here to include geometry as well. Like this. So we'll just copy that here and at the very bottom as well. Now, let's see what we have here. We'll still need core.h, so we're going to leave that. And we include color OpenGL.h. We're not going to be handling colors inside of this class anymore, so we can delete this. However, we do need to include geometry.h, since we are going to be inheriting from it. And vertex 2 and vertex 3 are still needed. Now down here under the class definitions, we're going to add geometry in front of the flat grid, and we're going to inherit from geometry like this. Now we need to rename our constructor and our destructor. And because of these changes that we're doing with the materials and the way we're going to be handling textures, we'll no longer have to pass in the color as well as the renderer. So we can go and delete those from the constructor. We only need the number of divisions in the X and Z, as well as the width and the depth in size. The renderer we're going to rename to be render OpenGL. And the other function we need is our update. So let's just include that. I just double checked, and render OpenGL should return a void, not a boolean. So make sure you change that as well. Then down here we have our members, the vertices and our texture coordinates, and the color. We can delete the color, we don't need that. And we can delete the renderer since we won't be using that either. Now, I'm going to take the vertices and the texture coordinates and actually remove them from the public members and put them into the private, since this class will now handle everything directly. We won't be able to access it from externally. Okay, so those are the changes we need to make to the .h file. Now let's open up the CPP file. You'll notice that the changes we're making are very minor. There really isn't very many things we're going to have to retype because we've done most of the work already earlier. We are going to rename the .h and the .cpp to contain geometry, so I'm going to rename this here. Geometry flatgrid.h. And as a matter of fact, just cut and paste this into all the places where we used flat grid. Okay. Now going back to the constructor, again, we deleted these two last parameters so we can get rid of them. And at the top here, we set our vertices equal to null, and we should do the same thing for our texture coordinates. T, and we're getting rid of the renderer. We're going to leave this check here, so don't touch that, but we are deleting the color. And then I think everything else we can leave the same, since we need to still allocate memory to create all the vertices and the texture coordinates as we require them. And if we run out of memory, then we clear whatever we did create and we just exit. The destructor we're going to leave since it's all okay. Render though, we'll need to change the return value and change this to OpenGL. And now we need to make a couple changes in here. Since we're not going to be using the render, we don't need the switch statement anymore. So we can go and actually delete this completely, which means we can get rid of a couple of these brackets. Let's see how many. These last two. And since we're not returning anything, we can just return directly like this. And let's just format this so it's a little cleaner. We're not using colors, so we'll delete this, and we're going to leave the normal part since our flat grid is still going to be flat on the ground with the normal pointing straight up in the Y direction. So we're leaving that. Depending on whether textures are enabled or disabled, we branch between this if statement or the one below. And if we are in here, we go and render everything accordingly. Otherwise, we render it without the texture coordinates. And down here, we can just change this to render OpenGL. Okay, that's, I think, basically all the changes we needed to make to the flat grid class. Now, to change the file names, let's go and close both the CPP and .h files. And the quickest and easiest way to do this is to rename, is to select the CPP file, delete it out of your library, and the .h file, delete it as well. Then go into Windows Explorer under Object Library, and in here just rename Flat Grid. So I'm going to add Geometry in front and in here as well. Now that it's renamed, we can go back and just right-click under Object Lib, click Add, Add Existing Item, and select those two. And there we go. That's all we needed to do. Let's just make sure we can build this. So select it and compile it. Make sure we didn't create any mistakes. Okay, then that's fine. So that's all we need to do to convert the flat grid to use the new system. Now let's go and create a brand new geometry. We'll call it GeometryBox that we'll be able to use to render a box to the screen. To begin, we need to create a new .h and .cpp file. So we can do this by clicking on Object Lib and selecting New. We'll create the CPP first, GeometryBox, and repeat this for the .h. Okay, in the .h file, this is what we should have. We define up here GeometryBox _ h, and we include geometry.h since we are also going to be inheriting from geometry. Remember, all of our objects that we're going to be rendering to the screen must inherit from geometry. We need to do this because in the code that I'll be showing you in the next VMK, you'll see how we link in all these geometry items with things inside the scene. So we always need to inherit from geometry. We have a constructor, which receives a width, a depth, and a height, and a destructor. And then we have our update and our render OpenGL. All of our geometries will have these four general functions inside them. There may be other functions inside of geometry classes, but those functions won't really be called directly from us. They'll be called internally to do some extra processing. Our member variables will include the width, the depth, and the height, which will be saved by the values that get passed in here from the constructor. And that's it for the definition. Now, before I show you the CPP code, let's go into PaintShop Pro here and take a look at how the box is going to be constructed. The box itself has 6 sides and 8 vertices. So there's the bottom face here, defined by 1, 2, 6, 5. We have the front face, which is defined by 1, 2, 3, 4. We have the right side, which is 2, 6, 7, 3. The top side, 4, 3, 7, 8. The left side, 1, 5, 8, 4. And the back side, which is 5, 6, 7, and 8. Now, the the center location of the box I've designated to be at the very bottom center of the middle, well, basically the middle of the bottom face, and it's designated here by this X. So in the X direction, to find these vertices here, 2 and 6, we're going to go a half a unit outward in terms of the width. So the width of this box is going to be the size from vertex 1 to vertex 2. That's going to define the width. But the center is going to be located exactly halfway between that width size. The height is going to be the distance between 1 and 4, so it's going to be the full height of the box. And the depth is going to be the distance between 2 and 6. And the center is going to be located halfway between the depth here. So just remember that when we go into the C++ code and take a look at how things are constructed. The box itself is going to be constructed of a number of quads. And what a quad is just a collection of 4 vertices that are ordered in counterclockwise order. So for instance, 1, 2, 3, 4. Notice that all 4 of these, when you count them through, they form a counterclockwise circle. And it's important that they do this counterclockwise. If you define the quads in clockwise order, then your box won't actually appear on the screen. And the reason for this is because we've turned off backface culling. And the way that backface culling works again is, if you remember back to when we were using the triangles, you have to define the surfaces counterclockwise. When we're defining each of the faces, the top, bottom, left, right, whatever, all of them have to be counterclockwise. And I'll show you in the code, I've actually commented which vertex I'm referring to, so you can refer back to this diagram and see that I truly am going counterclockwise. Now realize this though, when I define the front face here, 1, 2, 3, 4, that's counterclockwise. But the back face, if I define it counterclockwise, as in 5, 6, 7, 8, that's really not counterclockwise. That is counterclockwise if you're looking at it from the inside, but we want to only look at the box from the outside. So you would have to define it 6, 5, 8, 7. That itself would be counterclockwise. And if you can mentally rotate this box in 3D space, you'll understand why 6, 5, 8, 7 is counterclockwise and not clockwise, even though it may look this way on the screen. So just play around with those and realize that when you're constructing objects, if you're missing some faces, most likely it's backface culling. And to do that, to fix it, all you need to do is just reorder your vertices so that they're wound in the correct order. Okay, so here's how the box is going to be constructed. Now let's go into the C++ code and take a look to see how to actually write this up. So back in here, under GeometryBox.cpp, let's go and take a look. At the top, we include stdafx.h and GeometryBox.h, and then we have our constructor. And our constructor here should be called GeometryBox, and we pass in the width, the depth, and the height. And we check each of these values, the width, depth, and height, to make sure that they're positive. If they're less than or equal to 0, we automatically default them to be equal to 1. So we don't want a box that has no dimension in a specific axis. So that's what these first 3 checks here do. They just make sure that we have a value that's at least valid for the width, the depth, and the height. So we take those values and we save them inside as our member variables. Our destructor doesn't need to do any work since we're not using any dynamic memory. Our update, again, I'm not going to talk about this until later, so we're just going to leave it blank for now. And then we have our render OpenGL. Here's where all the work happens. So we have to define how we're going to be specifying our vertices. And as I said earlier, we're going to be defining them as quads. So every 4 vertices we're going to define is going to form a quad. And OpenGL will know that the 4 that we define, group them together, render something, and then select the next 4, group them together, and render something. Now, I've broken up the code into sections here. You notice this is the front, the right, the back, and so on. And each of these sections represent one face that we're going to be rendering on the box. So let's take a look here under if textured. The only difference between this section up here and this section down below is we include texture coordinates. That's the only difference. Everything else is exactly the same. So to begin, let's do the front face. The front face, we define a normal, and the normal is going to point in the Z direction. So it's going to be pointing straight out of the screen. The texture coordinate for coordinate number 1 is going to be 0, 0. Excuse me. And then we have the vertex coordinate. So it's going to be half the width. So it's going to move to the left, 0, and then it's going to be half the depth forward. And going back here, you'll notice if we start here at 0, we go half the width back, and then half the depth forward. So that's vertex number 1. Then we have the next coordinate, coordinate number 2. This texture's coordinate value is going to be 1, 0, and the value of the vertex is located half the width again in the positive direction, 0, and then half the depth forward. And if we go back here again, we go half the width this way and then half the depth forward. So there's vertex number 2. And you can go through this in detail, take a look to make sure all the coordinates make sense to you, and take a look at why I've chosen the texture coordinates that I did. Basically, with the texture coordinates, I've mapped out each face to be 0, 0 at the bottom left-hand corner, 1, 1 at the top right-hand corner, and then these ones fit accordingly. So there's our front face, there's the right side, there's the back side, we have the left side, the top side, and then the bottom. And that's it. I've labeled all the vertices here, numbered them, so that you can quickly just go through and take a look at all the vertices and make sure they correspond with the image here in PaintShop Pro. I didn't label them inside this case here where we don't have any texture coordinates, but they're basically the same. So you can go through and number them if you wish. So again, front, right, back, left, top, and bottom. And then at the end we need to call GLEnd just to make sure that OpenGL knows that we're done rendering all of our objects. Here we call begin with the quads. And that's it. So let's try and compile this, make sure it's okay. And it is, okay. So that's it for this VMK. We now have 2 different kinds of geometries that we can work with. So come back for the next VMK where we'll be modifying our scene class to implement a structure that allows us to create our scene graph. And once we have that, then we can actually start rendering. And hopefully by the end of next VMK, we'll be able to render these boxes and planes on the screen so you can actually start playing with the scene graph.